Okay.
There's here. Questions. All right.
All right, it's like it should be live. Yep. Great.
What? Yeah, it's live.
And let's see. I don't know if there's a, I assume there's a viewer count somewhere on here, but I'm not seeing one. Oh, one watching now right now. Well, that should be higher. at least two of us are looking at it. So, but hopefully that'll update. All right. And Sasha, I guess you're accessing it through the link from Meetup, so that should be the same thing everyone else has.
Yeah.
Right. Okay.
I'm going to post it where it started.
Okay. Okay, let's give it a little bit longer, see if people can start getting in. I see the viewer count starting to tick up, so that's good. So there might be a little bit of lag in terms of when that updates.
Yeah, I posted via live, so.
Right. Well, welcome everybody who's tuning in now. We're just getting set up, letting everybody join the session, and we should be starting in just a couple of minutes. Well, I guess we're waiting. Has anybody seen anything interesting at CES this year?
The only things I saw that were a little interesting was the stuff I saw from Razer. Like I mean, every year they put out concepts. I think the concepts are, the chance they're going to release them is, questionable. But
Right.
At least the concepts they did this year I thought were pretty cool. They took the concept from last year they did, which was the all-in-one mini computer that is like, it's the size of an eGPU, but it's a full desktop. And they're actually launching that. I like their new, like chair design with the rollable OLED panel that pops out.
Nice.
And then of course their new coronavirus mask I thought was pretty cool. Like I actually think it's unique in a very particular way that I think it might have product market fit for sure.
Yeah, definitely good timing. Are they actually shipping now, or is it going to be later on? They start selling.
They said it's going to take a few months.
Okay. Well, you want to just give it another minute or so, then we'll get started. Okay. Well, let's go ahead and get started on this. So welcome everybody to the, oh, actually, before I do that, let me start the recording. All right. Welcome everybody to the first event of 2021 for AR/VR creators. I'm Michael Oder. I'm the organizer for the Meetup group. First off, let's do a quick check with the people watching on YouTube. If you can see and hear us, just reply in the chat, just so we make sure that we're not leaving people out. There's a slight delay, so I might give you a couple of seconds.
Yeah, just keep me set up. Double check the name.
We're doing so too. If you're also interested in following the group elsewhere, we have a Facebook group that was posted in the Meetup chat, but I'm gonna go ahead and post up here as well. So it's me saying the link in the calendar is incorrect. So
It's recording. I need to update the link to YouTube.
Just FYI, the YouTube link that's on Meetup also is, or the YouTube link on the Meetup is incorrect as well.
It is.
It's already it's already incorrect again. Yeah.
Oh, okay. Let's see if we can edit that then. So I guess I can post this link. So what was the link that you're seeing?
It doesn't work. It's already it's the publish. It's just 1 minute video of recording.
Oh, that's just, I guess I went to the first one instead of.
Maybe you need to create the new one. Just streaming.
All right. Let's see, where's it let me? I'm not seeing where it's letting me edit the link. Let's see. Yeah, that one's not working. So you pasted one into the below in the chat.
Yeah,
oh, I see. Yeah.
It's just a video.
Oh, I see this. Okay.
I mean, are you like? Is there a place where there's a live link, like from your account? Can we just share that link?
Yes, I'm trying to see where we can. There's a live link. It's in the Meetup chat right now.
That link doesn't work. I will delete it. I'm deleting it right now.
Okay. There is actually a link that was posted. So the link was here. I will get it into this chat and share it with you guys.
Yeah. For some reason, I'm not seeing Meetup is not letting me edit the event just options. I'm not sure why.
You mean in the description?
It already started.
Oh, okay. Well.
Oh yeah. I mean, no worries. I can put post it on the comments.
All right.
People check and come.
Okay. So let's go ahead and get started then. All right.
Yeah. So that's the link. Just posted it. It's
okay.
in our little chat right there.
All right.
Okay. I will post it.
Okay. Well, thank you everybody for joining in. So AR/VR creators is we're based out of the East Bay near San Francisco, but we've been trying to open up the scope of our community to include people wherever they are at, who are working in AR, VR, XR, MR, right? Your creators or developers or builders, and we're here to try to help support you. We're a pretty small team right now. Currently, it's just myself and my co-organizer, Sasha Mitskakova. But if you're interested in joining in to help, we'd really appreciate it. So please don't hesitate to reach out. you can contact us either through Meetup or the Facebook group. And we definitely would be welcome any assistance. We're currently trying to schedule additional events for the next few months. And if you're interested in sharing your work or presenting a product or just showing off, we want to give you a platform. So please reach out to us. In addition to
reach out on Facebook, yeah. I mean, yeah, the best way to reach out in the Facebook group, ERVR creators, so I can post it in the chat.
Exactly. In addition to presentations, we're also organizing some workshops that focus on different tools or technology. So, for instance, right now there's a series on WebXR that's been organized and hosted by Isaac Goll and Kieran Farr. The next installment's part 3 of it's this Sunday. And if you're interested in the topic, please tune into that. They provide resources to get you up to speeding if you've missed the first couple events. But again, if you're interested in presenting a workshop, we definitely want to hear from you, so contact us. Well, today we have a pair of presentations I'm really excited about. The first is a presentation by Nima Zeighami. He's product manager for the LumePad at Leia Incorporated. And he's going to introduce us to the device and present some of the content creation tools Leia provides. Nima?
Hey everyone, what's going on? I'm Nima. I'm a product manager at Leia. I've been at the company for over 2 years now. Worked on the Hydrogen 1 when we originally had that. That was our first device we made with Red, which was a Lightfield phone. And I was the product manager of Pix, which has now become Leia Pix, which is the world's largest social network for 3D photos, has the most active users, has the most posts per day, and has a massive repository of data. We've put out a lot of research about that. We've put out research reports on how to use machine learning using stereoscopic imagery to create depth from mono images. And I can talk about that a little bit more later. But we put out a lot of research, and our newest product is the LumePad. And the LumePad is a product for businesses and creators to create stunning Lightfield content. So yeah, that's a quick introduction about me. Are we going to do intros, or should I just jump into the presentation?
You just go ahead and jump in.
Cool, sounds good. All right, so today I'm going to go through with basically giving you guys an overview of the LumePad hardware, as well as some of the applications that we use on the device. More advanced topics, if you guys want to dive deeper into it, would be how to create content using a Mac or a PC. But today I'll just show you guys what you can do on the LumePad itself, what kinds of apps are available, and how the entire product sort of works. One thing that I wanted to get into before we get into it is kind of what's unique about our technology. One of the core things is the diffractive Lightfield backlighting backlight that's a part of our LCD displays. So what we do is we create a, so LCD technology has multiple layers to it, but one of the core parts of an LCD is the backlight. All the LCD-based devices that you have a backlight, and those are what we would call a 2D backlight. Instead, what the DLB does is it is a light field backlight. We use like nanophotonics to create a layer of etched gratings within a backlight. So now there's 2 backlights. So there's the standard 2D one as well as a light field backlight. When the light field backlight's enabled, instead of light going in all directions like normally does the 2D backlight, the light is sent in very specific directions the gratings are guiding, which ends up creating a auto multiscopic effect. So this effect basically means that as you move around, you're getting unique views in each of your eyes, which shows stereoscopic information. So you're seeing a full 3D image without the need for glasses or anything like that. The things that make this unique compared to older technologies that I'm sure you might have seen, like lenticular-based displays or parallax barrier-based displays, is that it's kind of a few core things. So number one, this is fully switchable. So when you turn off the DLB, you get a full pristine 2D image. When you have a lenticular that's on top of a device, you can't really turn that off. There's some methods, and I'm not going to get into specifics there, that you could do that, but in general, you can't turn off a lenticular when it's in front of a display. With ours, when you turn it off, you get full pristine 2D, which means you have full backwards compatibility with all the old applications you use on traditional devices. In addition to that, it is brighter. So it is much brighter than most 3D displays. In addition, that's more comfortable. It has more views. The views repeat in a very pleasing way, meaning normally you can view lenticular or parallax vary at off angles, but they are significantly worse than the straight on angle that they're designed for. Our technology is very comfortable as viewing it from an angle. So if there's 3 people, like you have 2 friends over your shoulder, they're watching 3D with you, they'll be able to get a clear and comfortable image. On top of that, one of the most important things is that it's rotatable. So you can actually turn our devices in any orientation and still see it in 3D. Whereas most lenticular technologies, they're one direction, meaning if you take a product that uses lenticular technology and turn it on its side, you lose the 3D effect. So yeah, those are just a few reasons why we think that diffractive light field backlighting is a pretty interesting technology that will create the future of light field devices. We have been in a phone already. The LumePad's a tablet, and I'll be showing you that. We are going to be in cars starting next year. So 2022 model devices will start having DLB displays in them, mostly luxury and high-end cars, but eventually will roll out everywhere. And there's also other devices in the future as well. So we're pretty excited about this. Without further ado, let me get into it. Just to give you guys kind of a big caveat, I live in California, so there's a lot of light everywhere, and there might be kind of a glare on the screen. Of course, with displays like this, you really do need to see them in person to get the best effect. I'll try to reduce the amount of lighting in the room to see if I can kind of counteract that, but hopefully you guys don't hold it against me. There's not really much I can do. And without further ado, let me get to it. I'm gonna switch to the LumePad camera. One moment.
Okay, if you have any question, you can post on the Zoom chat or maybe on YouTube, the live chat, because I already see some question I'm going to collect, so we're going to answer by the end this talk.
Okay, so yeah, please drop all your questions in, and I'd love to answer them. So this is the LumePad. The LumePad is a about 10-inch Android tablet. It runs all Android apps natively. Right now, it's running with its immersive wallpaper on. The immersive wallpaper means that basically, to me, it looks like all these icons are floating, and the entire tablet, the background is pushed in multiple inches into the back. So it just looks like all these icons are sort of floating on the display. The hardware itself is pretty sleek. I'll show you guys what the back of it looks like. Actually, so this is the LumePad from behind. It's definitely a luxury device. It comes in 2 colors. This is the champagne beige color. It also comes in moon gray. On the back, you can see we have a stereoscopic camera as well as a flash. This is the antenna cutout, and then of course the logos. On the top, we have the microphone, a speaker, the USB-C port, and the headphone jack. And on the top, we've got the lock button. Oh, you can't really see anything. The lock button and the volume rocker over there. So that's sort of the quick overview of the LumePad hardware. And on the front, I'm sure as you can see, there is a camera array as well. So this one has a mono RGB camera, a time of flight sensor, and of course like a light sensor. So yeah, so as you can see, it looks like just a normal high-end tablet. But the interesting thing, of course, is the diffractive light field backlight. Let me tell you about some of the apps that we have on here. So we've got Leia. So Leia is the app that will allow you to capture 3D images. So it captures them in something we call Leia image format. Leia image format is a format that has custom metadata inside of it that explains the depth of the image as well as stores multiple images. However, it looks like a normal JPEG. The beauty of that is that you can send this JPEG to anyone on any device, and they'll get just a normal high-resolution 2D photo. However, if it's on a Leia device decodes it, and you get a full light field image inside of it. We think that's pretty interesting. As far as the video side of things, it shoots standard SBS video. We do have a Leia video format, but that's not really used for creators yet. That's mostly just for professional use cases. For now, we just shoot in standard SBS video, which means it's fully backwards compatible out of the gate with all of your editing applications. So if you're using Premiere or Final Cut or any other application that is stereoscopic aware, like maybe Sony Vegas, I guess it's Magic's Vegas now, but All those applications, you just edit video inside of them and it works perfectly. You can also use it on legacy 3D devices. You can put them on an old 3D TV that supports SBS and it will just play automatically. And then you can also view it in a VR headset or an AR headset. If you have like an Epson Moverio that does SBS by default, that would work, as well as any device that has a 3D SBS player. So you can get those on iOS and Android for use in Google Cardboard, or you can use virtual desktop on desktop computers or on Oculus mobile devices like the Oculus Go, Oculus Quest, Oculus Quest 2. And any of the videos you capture on this device will be fully 3D and you can see them inside your VR AR headset, which I think is pretty awesome. It's been a pretty good experience for me capturing stuff like that. Next, we have an app called Leia Stream. So Leia Stream is our take on YouTube, basically. Let me go ahead and launch into Leia Stream. Leia Stream has a variety of 3D light field videos in a lot of different formats. People can like and comment on these different images. You got notifications. It tells you who's posting things, who's, you have your own account. You can post your own content. So if you go shoot 3D content with the LumePad, you'll be able to play it back. Let me go ahead and play this SBS trailer real quick. Hopefully it'll launch up. So as you can see, you might not be able to tell that this is in full 3D right now, and it's actually 4V specifically. One of the things that we started doing is allowing both 4V and stereo viewing. So if you go ahead and hit this button, it switches from 4V, which is our Lightfield format, into pure stereo. So this is basically the standard SBS that you're used to. Lets you switch between different methods, so you have less of a look around effect because it's standard 3D, but you might sometimes, depending on the content, get more depth by switching to stereo mode. You can also automatically switch to TV. So if you just hit a simple button like that, you get full, pristine, high-quality TV, which is really awesome since this is a 2560 by 1600 resolution display. So it's super high resolution. I don't know if you guys can hear there, but the audio is also fantastic. It is a Dolby Atmos certified device. So the audio is pretty crazy. And yeah, there's a variety of different types of content that people are posting, converted content, natively shot content. Yeah, like let's try this one. This person used an iPhone. It's an iPhone video that's converted to 4V format using Lightfield Studio. Wow, that has a lot of depth to it. So one of our tools is Lightfield Studio for desktop, which, like I mentioned, is a more advanced tip on how to create content. But we offer full 2D to 4V conversion, which means that we use machine learning to take any 2D image, do depth estimation on it, and then create a full light field video out of it. This means that you can use all the tools that you already use, whether they're DSLR cameras, whether they're mobile devices, and shoot regular videos and immediately, well, I should say immediately, have them run through your computer, and then within 30 minutes to an hour or two, you'll have a fully converted light field video popped out of it. And that's improving all the time. And as you can see, there's just tons and tons of content on Leia Stream. There's some stuff that has been shot for fashion. So here's some work from Marc Jacobs that we have up there. We have aerial shots from drones, like ones that were shot in New York City. We have some that are shot in China. And yeah, there's just a variety of content on Leia Stream, and it grows with more and more content every single day. So it's a full 3D light field video streaming platform. Now, moving on, there's a few other core applications to the experience. I'd say probably the most core one is the Leia Player. Leia Player has a variety of different features. So it basically lets you play back any movies or photos, lets you play back 2D, of course, but also lets you play back SBS 3D. And SBS 3D lets you view it in both stereo as well as automatically converts everything into 4V on the fly. So you can view it as a light field photo or video without doing any extra conversion. It'll just convert on the fly, which is really good. These are all, I'll actually show you some stuff so you guys can see kind of what's going on here. This is a video that's shot on a 360 turntable. So basically using the disparity delta between the movement of the camera around this object, we can use that for perfect depth estimation. So this is just a beautiful light field video of this fruit. Let's go back. And then a Pixar video. So this is originally a stereoscopic 3D trailer for the Pixar movie Coco. And this was ran through our the stereo estimation system in Lightfield Studio. It takes a 3D SBS video and turns it into a Lightfield video. So yeah, and it has the same abilities of any player. You can jump between things, switch it back to 2D so you get the full 2D effect of it, and then obviously back to 4D. Pause it, get information about it, tells you exactly what it is, tells you what resolution it is, etc. Yeah, it's a pretty great experience. Now, for many of you VR and AR creators, I'm sure you've had a lot of experience with Equirectangular 360. We have recently started doing work on Equirectangular 360, and we're planning on adding that to Leia Player within probably a month or two. But we just recently did this experiment yesterday, and we think it works perfectly great. This was taken. This is a 360 of France. One of our partners created this, and it's pretty beautiful. And as you can see, it's still equirectangular, but this is a full 4D light field experience. And you know, these petals are coming off the screen. Like I can see them popping up. You know, they're kind of like floating above the device. It's pretty incredible. It's a very stunning experience. These flower fields go way back in the distance. These flowers are popping up out of the screen over here, as are these ones. Yeah, the light field effect is really pretty compelling. And there's a variety of content like that. Whether you're a drone enthusiast or you want to build a full stereoscopic rig, or you want to build a 360 rig, or you want to just shoot 2D and convert it, you can really make content for these devices in a variety of different ways. Also, things you shot on the camera. So, you know, pictures of my friends. Those are, you know, you can just shoot those and it'll just pop up. You can download a variety of different things. This is something I shot on another 3D camera when I was in Seattle. And then it automatically, even though it's just SBS, this is being switched into 4-view light field immediately on the fly. So this rock is kind of sticking way up and all that stuff's way back. My friend in the tree are just like right kind of in the middle, and then everything back there is pushed way into the screen. So obviously you really need to see this to get the full effect, but I'm gonna try to explain it as best I can. The other cool thing about this application is that it has a full editing suite. So if I go to pictures, I can take any of these photos, let's say this one. And if you hit this button, it takes you into editing mode. Editing mode lets you change a variety of things about the image. So if I go here, my options to change the depth, if I increase this, the depth increases significantly. However, certain objects might become misaligned. So then you want to go back to focus, and then you can change the focus of the object until right there. Now this is sticking way up and this is focused. There are some things in the back that are a little bit out of focus. So what you would do is increase the bokeh here, and that blurs the background. So now, I don't know if you guys can tell on there, but now basically this is sticking out fully in focus, and then everything else in the background is blurred out. This bird over here is also sticking out and in focus. So this basically allows you to kind of hide imperfections from when you really want to increase the depth of a single image. I'm going to skip that and go over to the next section. Now we've got brightness over here. Obviously, these are all the standard photo editing tools that you might be used to. So, you know, change out the contrast. Want to make sure all the colors really pop. Maybe bring up the saturation a little bit. And then we also have other features like color pop and hue. With this one, you can kind of change it so that the only things that have color are things that are really far up. So this is based on depth. So you can basically eliminate the depth in an image based on the depth, eliminate the color in the image based on the depth map. So you can imagine someone holding out a bright object towards a camera like an apple, and basically you're able to make everything else in the scene be black and white except for that apple they're sticking into the camera. And then obviously hue as well. But I'm going to go ahead and pop out of there. Simple things like rotate and crop are also available. I'm sure you guys know what those do. And then we also have machine learning based stereo aware filters. So this is pretty unique. So I'm sure you guys have all used filters in your camera apps as well as on Instagram. But what's cool about this is the filters are actually stereo aware. That's a pretty unique concept because normally when you run a filter on a 3D image, it's not aware that the objects on one side of the image, AKA what's in your left eye, is the same as what's in your right eye, which means their machine learning filters most often apply different filter aspects of the filter to the same part of the 3D image in each eye, which means that it looks off. So when you're viewing it in 3D, you're basically seeing something different in your left eye that you're seeing in your right eye, which is obviously a problem, and it breaks the stereoscopic effect. So instead, we have some pretty cool ones. If I run this one, takes a second, boom. Now you've got this full stereo aware filter that's doing a style transfer. So this is basically, each of these are styles that are trained on a famous painter's style. And when you press this, it switches to whatever that painter's style is, and then does a stereo aware style transfer of this filter. We think this is super cool. In the future, there'll be more filters that you can download, but being stereo aware means that you can apply these filters and the depth isn't broken. Everything still looks perfectly normal when you look at the image. And then finally, we also have a new feature called relighting. And so relighting uses the depth maps within the images to do full relighting of an image. Meaning, if I want to do spotlight, notice how the light is only on the subjects that are super close up to the camera. The cinematic one changes where the lighting is. And then, you know, basically each of these ones has its own lighting preset, which basically changes where the lights are coming from. So as you can see, there's like a colored light coming in from the side on this side and less light on this side. These are basically using the depth map to accurately throw the colors on there, which means that if you have a different image with a different depth map, it will be aware of that. Like, for example, if it was a person's face in a portrait, only one side of their face would be lit up and not the other side. So we think this is super interesting. In the future, we're also going to let you relight it yourself, meaning you're physically going to be able to move the point light around the image and then also move it in and out of the screen. So you could potentially put a light behind the bird, for example, so that you can see the light lighting them up from behind, but it won't be affecting the front of the image. So you'll just kind of see like a halo effect. So yeah, we have all these editing features built into the Leia Player, with more features coming really every time we do a release. So yeah, that's pretty exciting. The formats that are supported are 2D, SBS 3D, half-width SBS 3D, which was used in a lot of older televisions that couldn't support full width SBS for whatever reason. We also support, obviously, our formats, which include Leia image format, as well as quad, which is a pre-computed either JPEG or PNG, which has 4 views that are hard-coded into an image. And then in the future, we're also adding JPS support, which is a somewhat popular format for 3D images, as well as some of the other 3D image formats as well. So yeah, all those are coming into Leia Player. Now, there's other things like the Leia Loft store. The Leia Loft store is where you get all the applications for the LumePad, and every application in this store is a Lightfield application. We have tons of different games. Games are all different prices. We got like, this one's free, this one's $5, this one's $1, and just a variety of different applications and games too. So this is a DICOM viewer, which I might talk about later. But yeah, basically we've got a bunch of the top picks. We have some really popular ones that are on other platforms like Asphalt. We also have Modern Combat. And then Spirit Roots, which won a bunch of indie awards when it came out on the Switch, but we actually had it about a week or two before it came on the Switch, so we're pretty excited about that. And of course, this is the only platform where you can play it in 3D. For other people who are big VR fans, we also have Eclipse Edge of Light, if I can find it. There we go. This is a really, really popular VR app that won Mobile VR Game of the Year in 2017 from Upload VR and Daydream District. And I'm friends with the creators of this, and it's just a beautiful adventure game where you just explore this alien planet. It's just fantastic, and you can play it on our device. You can, of course, use a touchscreen to use the device, so just like use it with touch, but also some games you can use a controller, and it's a really great experience with the controller as well. Other apps that are really great are apps like Hollow Chess, so 2 people can play it. It basically looks like the chess pieces are floating off the board, so you're basically able to place chess pieces and play chess against another person on a table. You guys can both look at it and view the 3D at the same time. So that's a pretty awesome experience as well. And so that's what Leia Loft's all about. Leia Loft's the app store. All the Lightfield apps are here. We also have things like Leia Frame, which I'm not going to jump into today because it's not super interesting, but that basically turns the LumePad into a Lightfield picture frame. So after you've captured a bunch of content on the LumePad, you're able to use it as a Lightfield picture frame, put it on your wall if you want, put it on a stand, and then it also automatically launches. So once you've selected all the photos that you want in the Leia Frame, if you plug in the LumePad to charge, you can set it up as a screensaver where it'll automatically launch into your Lightfield image slideshow every time you plug it in for the night, which is really nice. Also on top of that, you could put videos in there if you wanted to. I'm going to move on to Leia Pix. So this is one of the applications that I'm the product manager for. Leia Pix is the Lightfield image social network. And without further ado, let me just jump right into it. So this is Leia Pix. When it launches, you get the home screen. The home screen will show you all the different feeds of all the new content that has been posted by the people that you follow, as well as all the top content posted by other top creators on the platform. So all these are new images. I've never seen any of these images before because there's always new stuff being posted every single day. You can always go to your notifications, and this tells you who's been interacting with your content. So an hour ago, I got a couple likes on my images. And then as you scroll down, you can see all the different people who are engaging with your content. If you go to Discover, Discover has big categories that you can check out. So we have our top 100 images of all time. We have the newest images, which gives you a linear feed of all the images that are being posted. We've got hashtag dog, which is one of my favorites. Just everyone loves pictures of dogs. And then over here are all the other top hashtags. So nature, food, art, flowers, dog, of course, animals. That shark picture is just crazy. It's like the shark's coming out of the screen. So just really, really beautiful content. And when you click on one, so let's say, let's go over here and go to dog. Now you've got a full feed of all the newest dog pictures, and you can just go through and yeah, enjoy pictures of dogs, which is just awesome. I never get tired of doing this. Then you have your own profile as well. This is my personal profile, all the pictures that I've taken, post pictures of my vacation, my friends, etc. And then if you have a cool picture that you want to share, like let's say this one, which was on a cruise, then you can go over here and you can share it. When you share images, you can just post them up into any platform that you want, and it'll just automatically pop in there. You can also bookmark, like, comment, etc. Hashtags obviously work. There's also a new export option, and this is available in Leia Player as well. But for any depth image, you can press that, and as you guys might be able to tell, the image is now moving back and forth. This is using the depth map of the image to create what is traditionally called a wiggle GIF, but we call it a Lightfield animation. Unlike a wiggle GIF, this actually creates a variety of in-between views, which is why you're seeing smooth motion there. Now, we also have the option of making an actual GIF, but this one can be exported as an MP4, which is of course higher quality with less compression than a GIF has, but you can post it anywhere you want. It also works on Instagram. So if you're taking 3D photos and you're wondering, well, man, this is really awesome, but I wish I could show 3D to other people. It sucks that I can only show 3D to people with other Lightfield devices. Fear not, we have a solution for you. Create the Lightfield animations, send the Lightfield animations to others, and they'll be able to get a taste of what the image that you created is. We also just launched a new feature called Leia Pix Prints, which goes over here. And this basically lets you choose whatever photos you want, like maybe this one of the skateboard, and this one of the food, and this one of my cruise, and this one of the chicken. And then over here, now lets you choose the quantities of images that you want and basically order physical lenticular prints of these images. These are the highest quality lenticular prints that I've ever seen. I've tried to order from a variety of different places, and these are the only ones I've seen that really both meet my quality bar and aren't prohibitively expensive. We partner with the amazing Z-Axis prints, which are known to do the best artisanal prints in America, basically, in the lenticular space. And basically, when you do the order here, we take your Lightfield image, we do a Lightfield image synthesis processing on it, which creates a variety of additional views, and then we send those views over to the experts, who then print it out, interlace it, and then put a lenticular film on top of it. So they're hand done, and the whole process is automated for you. So yeah, and then obviously you want to upload an image, you just go there, and then your images pop up, and you choose an image you want to upload, and then you upload it. So that's Leia Pix, and you can obviously find something cool here. I'm like, wow, this is pretty cool. Then you go over here and you can just comment on it and start conversations with people. So yeah, that's what Leia Pix is all about. There's a few more apps I want to show you guys before I'm done. Leia Viewer is one of them. We just announced that we have a partnership with Sketchfab. And so basically when you go to the Sketchfab Explorer, it lets you go look at all of this content that's on Sketchfab, and you can just browse Sketchfab, find something that you think is cool, like this one, that looks incredible. Go to download it. And boom, once it loads up, oof. Looks like this is a big one. Sorry about that. But ultimately, you can use any 3D model that you want. 3D models you create in Blender, 3D models you create in, 3D scans that you do, photogrammetry that you do. You just choose that content, and then you can view it on LumePad. Since this one's taking a bit long to load, I am going to cancel if it lets me. Oh man, I'm locked up. Let's just launch into one that I already know I have downloaded, like the pumpkin. There we go. So now this pumpkin is fully in Lightfield. You can rotate it, you can size it down, size it up, go really check out the details in there. Change the depth of the image. So now it looks like it's like mouth is sticking out of the screen. It's pretty crazy. Switch it back to 2D if you just want to view all the content in 2D. Then you've got a bunch of other options. You can change the lighting effects, change the brightness on the object, change the rotation of where the point light is. So as you guys can see, I'm moving the light around. Change the color of the light, color the background, change the effects, add some bloom, add some depth of field, change the materials too. This one's really fun. Let's switch it to metal. Boom. Now we've got ourselves a metal pumpkin, a carbon pumpkin, and you can do this to any model you want. So our new model viewer is pretty amazing. So take any of the 3D models you create, take anything from Sketchfab, and basically you get the option to play with it. Here's some of the Lightfield apps that we have. We have our dungeon demo. So I'm gonna show you the first real-time 3D app that I'm gonna be showing you. This is a dungeon demo that's running in real time in Unity. So all the light rays that you're seeing just come straight up out of the screen. There's a bunch of particles that you'll see the particles float above the screen. The dungeon itself has depth. You can see like into the screen. It's a pretty incredible experience. And this is running real time on the LumePad right now using the Unity game engine. And of course, you can create your own Unity applications as well. We also just launched very recently our Unreal SDK. So Unreal Engine is also supported. Other Lightfield apps we have, I've got a bunch of games here. This is the world demo. This is made with Unity as well, just to show that we don't 100% only do fun and games and art. We also have some real use cases that are pretty interesting. So this world demo is showing a real map that you guys can see. And it is, of course, of San Francisco. So this is all using worlds data, WRLD, and then this is a full Lightfield application. So when I bring this over here, these are all sticking out of the screen and basically gives you a better experience of viewing a map. You can find parks. Yeah, it's a pretty incredible experience. Yeah, so that's one of the real world demos that we have. On top of that, we have Clay, which I'm going to show you in a moment. And then I'll also maybe show you guys our VR player because that's something new that we just did and we're pretty proud of it. But Clay, you can create art. So tap this, changes the colors. Let's change the size there. Let's change the depth there. And then let me switch the depth to the other side. There we go. So this is a pretty cool experience because the light field really makes it feel like you're putting your fingers into clay and you're pushing clay in and pulling clay out, and really makes you feel like you're playing with like a real thing when you touch it. So you can sculpt different things, and it's just kind of a fun art experience.
Like a ZBrush, it kind of remind me.
Yeah, exactly, something like that. And the last one I'm going to show you guys is this, which is going to be much history. And this is a 360 video, which is the People's House with President Barack Obama. It is a high-end experience that was done by Felix and Paul. But this is it's a pretty interesting experience to be able to see a 360 VR video without a headset. So yeah, and you can launch all sorts of content too. So if I press this, it will let me shoot this one, which is the same experience that you guys saw in 4V earlier, and it's been a little bit crashy, but basically you can just run 360 and VR 180 content on this device, which is pretty amazing. And we also have a forum, and you guys can go check out the forum. This is the progressive web app for the forum, and you can learn anything you want. We've got the LumePad section, all the app suite, which means that basically it's a one-stop shop for development. You can go to the forum, ask your questions, create content on the device, shoot content on the device, edit content on the device, take the content off the device, put it on a computer, make some edits, create new content, bring it back onto the device, test it out, put it somewhere, let people view it. LumePad is really an ecosystem that's created to give you, as a creator, all the opportunities and possibilities you could possibly want. And it's meant to support creators and artists to achieve their vision in a completely new light. So that's pretty much the full extent of my overview of what's possible on the LumePad. There's a lot of other simple things like 2D applications you can run that run in full resolution, but I don't need to show you guys that. I'm sure you guys have used 2D apps in the past before. And there's even more apps that I didn't even get to. There's just a variety of Leia apps that we have. Our Spotlight application, nightly applications, there's a bunch of experimental apps that we have that we're working on. There's more content coming literally every month, if not multiple times a month. Sometimes every single week we have a new announcement to share. So that is it for LumePad. So thank you guys for tuning in to my little presentation, and I'm available for questions as you have them.
All right, so thank you for the presentation. Actually, we have a few questions from YouTube.
Awesome.
And I already collect them. For the first one from, I'm sorry if I don't read the right name, Juan David Ramos. How does the resolution compare between the Lightfield and the regular mode? How does the resolution compare between Lightfield and the regular mode? Yeah.
Yeah, that's a really good question. So it's a little bit hard to quantify because I'm going to tell you guys what specifically happens, and then I'm going to tell you what subjectively happens. So objectively, there's actually, we call it 4-view, but it's actually 16 independent views. And the 16 views is why you're able to rotate the device. So you get 4 views duplicated 4 times vertically. So there's 4 horizontal views that are duplicated 4 times vertically when you're holding it in landscape, and then when you turn it into portrait, it's again 4 views duplicated 4 times vertically, which is why you're able to view it in multiple orientations. So because of that, if you take just that raw number, 2560 by 1600, you could just say, okay, then that means the resolution is cut 16 times from 2560 by 1600. So if you look at that, you'd say, okay, well, then that means that the resolution per view is only about 100 pixels wide. But that's not entirely correct because basically we're duplicating the views 4 times, which means there's really 4 times the amount of pixels per each independent view. So then you're going to say, okay, well, that means it's 400p, right? Well, that also gets confusing. As I'm sure many of you have become aware, stereoscopic displays, basically the effect of having stereo, having a unique image per eye, gives your brain kind of an extra, a bit of processing. So it's the same thing with VR. Like if you look at the pure resolution of what the original Oculus CV1 or the Vive were, they're really horrendous per eye. Like per eye, you're going to be like, wow, this is like less than 720p. And then that 720p is wrapped around my entire field of view, which means the part that I'm looking at is even smaller than that. But they don't look that bad, right? They look like, I'd say it was somewhere between 720p and 1080p. So this is the same thing, but even to a bigger extent, because you're obviously viewing a tablet from arm's distance away. I would say the subjective experience is around 1080p 3D. So it's very similar to what I get when I'm viewing a 1080p 3D image on my 3D monitor or on my 3D projector. And it does depend on the content. So some content, like some photos, looks even better than that. It looks close to full native resolution 3D. Some content looks worse than that. Content that's not designed great, it looks closer to the true resolution of like, let's say 400p per view. But I'd say that the vast majority of content subjectively feels like 1080p 3D, but objectively, as I said, it's somewhere around 100p per light field view, and then 400p because it's multiplied by 4 with all those pixels. And then because also another complicated part of it is unlike just pure stereo where there's 2 views, the light field views actually kind of overlap on each other. So each of your eyes sees one primary view, but sees parts of each of the views next to it, which then your brain all fuses together into one clear image. So it gets really, really complicated. But again, objectively, you have the answer. Subjectively, I'd say it's around 1080p 3D, give or take a little bit. But that's just my opinion.
Okay, cool. Oh, okay, there's another question from Basso. So are those two separate sets of light sources, with one of them as a standard blue and another for the diffraction light field, the backlight? So the question, are there two separate light sources? I'm okay, the blue is like a BLU spelling.
There are two separate backlights, yes. The other backlight's not blue though, it's white light. It's like standard white light. So yeah, there's the standard 2D backlight, and then underneath that is the DLB. And that basically, wait, maybe the DLB is on top of it. I forgot, to be honest, but basically there's two backlights. We can actually turn on both at the same time. So when you see the immersive wallpaper on the home screen, that actually is both backlights working in tandem. The reason for that is by doing that, all the icons that you see, the icons are in full 2560 by 1600 2D resolution because they're on the zero disparity plane. So everything that's on the zero disparity plane, AKA on the actual location of the display, you can run those at full 2D resolution. Then the immersive background is running as a light field, which is why it looks like it's pushed in like 6 inches into the screen, which makes all the icons float. But instead of the icons being in the reduced resolution of 3D, which doesn't benefit a flat object that's on the zero disparity plane, it runs in 2D. So basically we have both backlights running simultaneously. And in the future, we're looking at doing other crazy things like being able to modulate both backlights at a super high frequency, which would then allow you to do things like have a single object on the screen be a light field object and have everything else be a high resolution 2D. So like if you're reading a newspaper article or something like that, all the text would be full resolution 2D and then the image of the article would be a 3D image. Lots of things like that are kind of in the pipeline, and we're making really good progress towards it.
It's awesome. Okay, another question from Cedric Villani. Do you have to set the parallax, the barrier distance?
So there's no parallax barrier, so you don't have to set a distance for it. The diffractive light field backlight does have an optimal viewing distance, just like most 3D displays do. It's designed around an average IPD, and we have created the diffraction gratings to be designed for holding a tablet at a normal tablet viewing distance, which is like about an arm's length for an average IPD. So if you go much further than that, the 3D effect starts to diminish. And then if you get like, I've tested this before, if you get about 20 feet away, it collapses to 2D. So if you're like more than 20 feet away from the LumePad, it just looks like a 2D device. And then if you get too close to it, the disparity is too great, so it looks uncomfortable. So you have to hold it at a good distance. Part of what we're doing with the time of flight sensor that's on the front is actually identifying how far away you are, which not only allows us to increase the quality of the, by the way, this is not turned on yet. We're looking to turn the time of flight sensor on in a future OTA in the next few months. But once it's turned on, it'll basically make it so images look even better at whatever angle you're viewing them at. And then if you get too close, it'll just say you're too close. You'll get an error that pops up on the screen that says, you're too close, please back away from the device for the optimal viewing. So we're trying to make everything be very foolproof. So you're always gonna have a good experience no matter what.
Cool. Okay, other question from the user Previ1. How high above the screen are the image floating?
Yeah, it depends on how you create the image. It's the same, there's some, it's no different than other 3D devices, really. There's some mathematical thing that you can do, which is basically based on the width of the display and based on the disparity of your eyes, you can calculate how far up an object can be while you can comfortably fuse to it. If you're running it in stereo mode, I've seen things stick up more than like 6 inches. You know, like if there's a super deep 3D photo that's shot with something way out in front of it, I've seen things stick up more than 6 inches. On average though, most of the content I shoot, I try to get it like, let's say anywhere from like 1 to 3 inches in front of the display is kind of the most that I'm comfortable doing, because I want it to be comfortable for everyone and not just 3D enthusiasts. And then behind the display, though, I go pretty far back. But then it does collapse at a certain point so that all the things super far back are just on a single plane. So I'd say that normally I do like anywhere from like 3 to 6 inches backwards, and then 1 to 3 inches forwards is most of the stuff that I design. That's just all rough numbers, but yeah.
Cool. So let's go to another question. So from the Cedric again. So the ML is calculating the image shift on the fly.
So it depends. We have a variety of different ML algorithms. So when you capture an image using Leia Cam, we already estimate the disparity immediately. Like as we save the image, there's already a disparity map that's built into it. If you are importing a 3D SBS photo or video from another source, when you play it back on Leia Player, yes, it in real time will automatically take that 3D image, calculate the disparity map, turn it into a 4V image, and show a 4V image, and that's instantaneous. As soon as you tap on it, it just happens. When it comes to video, we're actually using a different ML system that's also real time that we call Go4V, which is taking the 3D video and then turns it into a 4V video on the fly as well. So it's all in real time, which is pretty cool. And then on Lightfield Studio is not real time. Lightfield Studio is a high-end professional tool when you want to get the absolute highest quality, least artifacts, most complete videos, like for when you, like let's say you're a Hollywood studio or you're an indie filmmaker, and having it run on the fly is just not good enough for you. You want to really control it, make sure it turns out perfectly. Then you use Lightfield Studio, and Lightfield Studio is not instantaneous. Lightfield Studio, like if you have like a 2-hour movie, you can expect to take like 1 to 2 days to render the Lightfield video from that 2-hour movie. If you have like a short that's like, let's say like a 5-minute short film, yeah, that would take like 30 minutes to an hour. But it's not real time, but it does give you the highest quality. But basically there's both options. So for consumers who don't really care, they just want to take their, they want to watch the Avengers 3D that they ripped from their 3D Blu-ray and view it on the LumePad. They can just instantaneously view it in Go4V. It looks great, no hassle there. But for creators, we do have additional tools that are even higher quality and are, lossless and perfect. So both of those are options. And so yes, there are real-time options and non-real-time options.
Awesome. So other question from Cedric, is the SDK only for the pictures and the video converting, or it's other access to more?
No, actually, our SDKs, the main things they're focused on is real-time content. So the Unity and Unreal SDKs are focused on real-time. The Maya SDK is obviously focused on creating 3D models. Same thing with the Blender SDK is for making 3D models and animations. So most of our SDKs are based on real-time. However, we do have a native SDK, which you can use to create any type of Android application, even if you want to use like pixel art or make like a 2D application, make your 2D UI float or something like that. We have the Android native SDK. We also do have our new media SDK, and the media SDK is exactly for what you're talking about, which is for photos and videos. But no, I would say the main things that our SDKs support is for real-time software. And then we have different like functions within our SDKs that will let you view photos and videos. So as an app creator, you don't have to really worry about that. If someone has created photos and you want your app to basically, who knows, to extract a depth map, for example. Like you don't have to do the work to create all that. You basically use our SDK, tell the person to drop their photo in, you move the file into that decoding part of the SDK. It'll just decode it. You get all the stuff that you want. You can do whatever you want with it. So yeah, our SDKs mainly are focused around like real-time 3D applications.
Cool. Let's do 2 more questions. We should go switching. So other question is like, what is the native resolution of the display?
2560 by 1600.
Cool. And another question from Alan Roster. Do you have any apps to display 3D graphs or like 3D data visualization?
We do not have any data viz apps yet. That would be that is a big missing piece to our offering. If you're interested in making one, please reach out to me.
Cool. And what are the best way to reach out to you?
Great question. So if you want to reach out about LumePad specifically, please reach out to my email, which is nima.zeighami@leiainc.com. And it's nima.zeighami@leiainc.com. If you want to just talk to me about 3D or VR or tell me about an indie game that you made, I'm always looking for online friends. You can find me on Twitter at Nima Zeighami. So NIMAZEIGHAMI.
Cool. Thank you.
Thank you
Nima.
guys.
Thank you so much, Nima. That's great. So let's move on to Karl. So Karl Guttag is the Chief Science Officer at Ravn, and he's an expert in AR displays and optics. And he's going to break down some of the factors driving display and optic selection in AR headsets, and how those factor into design. So, Karl, if you could go ahead and take it away.
Yep. Hi there. Well, let's see if we can get the screen go. Hopefully you can see the screen now. Yep. Well, we're going to try to give a quick topic. Went through the topic and all, and I ended up keep adding slides to this. So it's going to be a fast-moving overview of the subject. So I'm just going to hit a few high points per slide and go with it. Let's see. There we go. Real quickly on my background, I was an IC designer, came out of university, studied electrical engineering. I was 20 years with Texas Instruments. I was the youngest fellow in the history of the company. After 20 years with TI, I went out in the startup world and started getting involved in display devices. I've been in 4 display-related startups in the last 20 years. So I've had 20 years, kind of 2 careers. One career in the large company world working on silicon, and the last 20 years working on mostly display devices for about the first 10 of the next 20. And then the last 10 years, give or take, I've been mostly focused on more system level products using displays. So I also do a little intellectual property consulting on the side. I have 150 US patents. I've been involved heavily in graphics. So most of my career at TI, I was working on pixels and graphics devices. I'm probably best known today for my blog, kguttag.com. And it's often said about my blog that we love, and this is actually a quote from somebody who came up to me at a conference, we love your blog when it's not about us. I tend to be very analytical and critical of what's going on. So I've been around the industry over 40 years, so I've kind of seen it all and done it all. I'm going to start with just a few basics. You know, we all, basically every thing I ever see always seems to start with Ray-Ban sunglasses and ends up looking like HoloLens. When we talk about the images we see, oftentimes people publish their ideal images or computer-generated images, or in the case, this is a HoloLens 2 camera feed. This is what it actually looks like. I believe my blog has posted some of the best and most accurate pictures ever taken of the HoloLens, at least ones published publicly. So I go to great lengths to try to get something that looks very much like what the eye sees. So this is kind of what you see on your camera feed on the left, and this is what your eye sees on the right. So there's quite a bit of disparagence there. Basically, AR is a very hard thing to do. We're trying to do more or less 3 main things. We're trying to combine, the display device is often small and too close to the eye for you to see well. So we're trying to combine that. We're trying to change the focus of the display device so when it's presented to the eye, it's in focus because it's actually too close to the eye for it to be in focus. The second thing we've got to do is we've got to combine the real world. And this is the really hard problem, that in this, whatever we do for combining optics, and this is meant to be very generic, it's going to have some bad effect on the real world and some bad effect on the display. So all optics do some level of damage to the real world and the virtual image, either dimming, distorting, polarization or diffraction and all kinds of other things. I'm not going to go through all these, but these are kind of my 23 deadly sins, or list of 20, the kind of a matrix of problems to solve. They go for everything from transparency to brightness, contrast to cost to power to weight. I oftentimes say, and oftentimes when you try to fix one of these things, you have a negative effect on other things. I usually say this is solving an n-dimensional chess problem. There's just so many different factors. And this is one of the reasons why, what is it, Google Glass came out, 2013, I guess. So 7 years later, still trying to get there. One of the things people worry about a lot is transmissivity. This is particularly important in social factors. People want to see the other person's eyes, but also you want to be able to see the real world. There's quite a variety in what people call augmented reality. And by the way, I'm almost exclusively talking about augmented reality today. And within that, I'm talking about optical augmented reality, i.e. where you look through some kind of transparent thing. So we go for everything from almost 80, 85%. Magic Leap was only 15% transmissive. And then in between, you have the Nreals and other stuff that are in the 30 to 40% range. Very simple optical concept. Most simple optics don't do much in the way of magnification. The way that we magnify is we actually move the eye closer to the screen and then use the lens to focus. So the main function of that lens can be thought of as to function the image. To focus the image. What I did here real quickly is I took a camera that simulates the eye pretty well, at least for this purpose. Put it about the distance, put it at the distance the eye would be from the camera, the distance the eye would be from an iPhone. This is for a little VR adapter. And I take the picture at this location, then I remove the headset, take the picture from the same location. And nominally, magnification is measured at 25 centimeters or 250 millimeters. Well, if I do that, we find that about the image is going to be magnified through that headset by about 5x. But about 3.5x of that comes from the fact that the camera has been moved closer to the screen. So really about 70% of the magnification is due to moving it to the screen. The lens is not making the image bigger. This becomes important because if we start with a small display, the easiest way to make it bigger is to move that display much closer to the eye. So why is AR so difficult? Well, AR is not just a little harder than VR, it's a lot harder. Optical AR is very, very hard. Part of the problem is where we want to put the display is right in front of the eye, but if we do that, we block your vision. So VR get to take the prime position. They also got to use a cheap flat panel display and block off all your vision. So that they can use some fairly simple optics to correct. Whereas with AR, we have to somehow take a small display and make a big image out of it, which, going back to the prior slide, is very difficult. And so we've got to route it to the eye, and we have to combine what's in the real world with what the eye sees. And on top of all this, when we build these little tiny displays, many of the pixels are only small integers of wavelengths of light. Another basic principle is light goes in straight lines unless acted upon, unless it goes through a medium. So if we look at light rays, if I want to illuminate one corner of the eye, I have to have a light ray coming from that position at that angle. So if we move the optics further from the eye, like we don't go right in front of it, but as we move out from the eye, the optics have to get forever bigger. So this becomes an issue. We also have to illuminate, and this is another concept people talk about, is the eye box. Basically what that means is how much can your eye move? If your eye moves, can you still see the image? So another way to look at an eye box is to say, look, if I was looking in a mirror, a small mirror, and looked at something in the mirror, If I move my head, it immediately starts cutting off. You've basically got a small eye box. Now, if we made a bigger mirror, then you can move your head and still see the whole image a little bit, move your eye a little bit. Another way around this problem is to do what they call pupil replication. These are pupil replicating waveguides. Probably the easiest to understand is a Loomis light with partial mirrors. And what they do is they take the image and have a partial mirror. Each of these is like 10% nominally. Loomis actually uses less than that, but I did this for the simple example. So what we did is each mirror is a little more reflective. So wherever the eye is, it actually ends up seeing the same image. Note this, each of these mirrors has the entire image, not just a fraction of it. Let's see. So diffractive pupil replication, which is more common, such as the HoloLens 2 and probably half a dozen to a dozen companies now, it also uses pupil replication, but on a more microscopic level. We'll just leave it at that. The other big thing to get here is another thing I'll talk a lot about is nits. And if you don't know what nits are, they're basically a measurement of brightness of light coming into your eye, very simply put. So if we look at all the light that comes out, and one of the easiest ways to think about it is to say, well, if I had a stream of water, and let's say these two streams on the right were coming out at the same amount of gallons per minute. So the same amount of water is coming out. But in one case, if I put my hand in front of this in a tight stream, it's going to come out very with high pressure or high force. And in this other stream, it's going to be all over the place, but at a much more diffuse force. So this is what we call, so for the same amount of light, we get lower nits if we spray it out all over the place. So in our case with near eye displays, what counts is what meets the eye. Turns out that this kind of light is really good for like a computer monitor where your head's going to be moving all over the place. But when you want to use something like AR, you want the light to be highly compacted. By the way, for the point of reference, a cell phone's about 500 nits. A computer monitor is somewhere between 100 to 200 nits. But if you go outside and you're going to wear your AR headset, if you're looking at concrete has about 10,000 nits. So there's a lot of light out in the real world when the sun's out. I won't spend too much on this other than to bring up this concept of étendue. What étendue basically says is if you collimate light, try to make it come in straight, or you shrink the image size. You can do one or the other, but you can't do both. As you try to make the light collimated or moving in very parallel straight paths, you have to make the path of the light bigger. If you try to reduce the size of the light path to a smaller image, and this is what we got to do when we enter into these pupil replicating waveguides, well, now all of a sudden the light's not collimated. So effectively what ends up happening is you take your fan sprayed out light that you're doing to collimate it and running it into a funnel. So very little light gets through. Now, you'll hear about people using micro lenses, arrays, and whatnot on top of things like micro LEDs. And what they're trying to do is collimate down at the pixel level. Because once you have the entire display, you can't collimate you can collimate the image, but you can't straighten out the light rays. You have to do that right as the light rays are coming out. This is this concept of étendue. Étendue basically says that for a given area of light, the product of the angular diversity of rays is always getting worse. So one of the big things we see out here are pupil expanding waveguides. People like pupil expanding waveguides because they're thin. The problem with pupil expanding waveguides is they're very inefficient. This idea of kind of funnel the light into it, we can lose about 50x of the light. So only 1/50 of the light from most display from like an OLED or micro LED can make it into the typical waveguide. You lose another 50x because we're going to take the little bit of light that makes it in do, and we're then going to immediately turn around and spread it out over the entire exit area. So we're going to expand the image back out. This has the advantage of making the projector small, which is a good thing. We want the projector to be small and lightweight, but it means that it's very, very, very inefficient. When we net this all out, we could get about 1/5000th of the nits in to nits out. So that's a huge loss. So even when you hear about things having thousands of nits, well, if you start with 1,000 nits in, you're going to get less than 1 nit out, which has been the big killer for trying to use these with, say, OLEDs. Even if you had a bright enough light source, there's still issues of battery, heat management, and weight issues. One factor in this is one of the big factors why you're seeing people look at, it's causing people to look at laser scanning more. Laser scanning does not have the severity of this input collimation issue. So we've already talked a bit about diffractive waveguides. The most famous one these days is HoloLens and HoloLens 1 and 2, but it's been used in a myriad of products, Wave Optics, DispelX, Magic Leap. They all use diffractive waveguides. DigiLens, another company out there doing it. So there's many, many manufacturers. You get a large eye box, you can get a pretty large field of view. There are actually people getting field of views even greater than 60, going up to 70 and 80 degrees. It's thin. That's the good side. The bad side, poor efficiency, poor image quality, lots of, and I'll talk a little more about that later. And you get waveguide glow, or really what I call front projection, and you get very poor uniformity. So the image quality is not there. There's a slightly different technique used by reflective waveguides, or reflective pupil expanding waveguides, really. A company called Lumis does a lot of that. And it's thin. It has all the same advantages. It has actually quite a bit better image quality in every test I've ever run on it. But there's only a few manufacturers, and the issue has been getting cost. Now, the company Lumis is working to try to improve that. They just did a new deal and a new announcement with Shot, and they've got this really small and enticing model that they're just developed with Shot. So we'll see how that works out. One thing about these, they've been able to get like over 4,000 nits out of these waveguides, whereas something like the HoloLens is only about at 500 nits. 500 nits really isn't enough for outdoor use without needing really dark sunglasses in front of it. Whereas at 4,000 nits, you're starting to talk more of an outdoor product, or ability to use it outdoor. So I won't go too much into this here. One of the biggest points I like to make on this slide, though, is that the orders. What happens, the way a diffractive waveguide works, if you don't remember your fixes, it didn't have it, is basically it bends wavelengths. When you go through a grading process, either reflective or transmissive, light will get bent as these gratings approach the wavelength of light. Light will get bent, and it gets bent kind of like a prism. It gets separated into various orders. Now, the good news is that allows them to bend the light and bend it in fairly small spaces. The bad news is there's these wasted orders. One of the biggest things you see coming all the time with these things is called waveguide glow. And what happens is they're projecting half of the light. As much light comes out at you as goes towards your eye. That's why when the guy looks at you the wrong way with these, you get this glowing eyes effect. Not very flattering. By the way, one thing I'll point out, I've used several images here from a book by Bernard Kress. He's written an excellent book available on SPIE, Optical Architectures for VR, AR, VR, MR headsets. And that's by Bernard Kress. It's an excellent book, just compendium of good information. Okay, so for this one, I wanted to compare, this is a slide comparing HoloLens 1, which also used LCOS, with Magic Leap 1 and Lumis waveguides. And so it kind of gives you two of these diffractive waveguides and then one of these reflective waveguides. One thing I will say is, I should point out, the Lumis is displaying almost twice the horizontal pixels. It has almost twice the horizontal and vertical resolution. of the other two. So it's able to pass through a lot more resolution. Magic Leap had a lot of problems. Their image quality was pretty poor. Even HoloLens 1, the resolution was moderately okay, although like I say, it's half of what this is being pumped through Lumis. Still had a lot of color uniformity problems. This is kind of the classic of diffractive waveguides, is how do they control color? They can compensate for it, but you give up color depth, and even when you compensate, it's never going to be really perfect. Another way to go is really cheap. So we see a lot of these things where we have a large off-axis curved semi-mirror. One of the more successful variants right now is Mira. Mira just got in. It just got announced a few weeks ago that they're doing the Mario Kart. They're in the Mario Kart ride at Universal Studios Japan. I think it's going to be released, depending upon COVID, around February, they say. But you know, the advantage is it's cheap. You get a pretty good image. You get a large field of view. You get a large eye box. You got large eye relief. That's all good. That made it really good for building this. If you're going to put these out in a theme park or something, that worked really well. The downside is, and I'm showing this on an eyeglass, you can see how this is an uncorrected image. It's very well distorted. What may not be as obvious is you can maybe tell that it's in focus here and it's out of focus there. The reason for that is focus is also running out. So not only are you distorting the image, you're also distorting the focus as you run out. So, and you can't correct for focus. You do kind of rely on the eye to do it. If your eye's concentrated down here, you'll let the eye do it. There's also something kind of in between. Active Look, which is a part of micro OLED, has a thing where they're doing a similar thing, but on a kind of a small scale. And you guys may remember Meta 2, and I believe RealMax Quan, that's a fairly recent thing. It's also doing more or less this, although I think they're maybe a little bit different, but it's still an off-axis, very thin look. And as soon as you, and the reason why I brought this up first is because it's popular in some products, but also because it kind of sets up for bird bath optics. And we'll be talking about them in a minute. The main thing a bird bath does is gets away from this off-axis problem. It's going to put a beam splitter in there, which is a downside. The beauty of this is you go straight from the display back to the optics and back to the eye. Well, with bird bath, they're going to get a little more complicated. I'll show you how that works in a minute. But bird bath is still fairly inexpensive. You get very good image quality, particularly if you use OLED microdisplays, such as Sony's the most common one used today. You get no chroma aberrations because you're using a mirror, and mirrors don't tend to have colors spray out. So you get very good image quality. It's on axis, which gets rid of a lot of the distortion. It works with low brightness, Lambertian displays, supports a reasonably wide field of view, but it does get bigger. The bigger the field of view, the bigger it gets. The cons is the form factor. When you look at this from the side, it's pretty thick, and most of the weight ends up out here. And then it's a little bit heavy, and the weight is put out way out on the nose. And one of the things is the further you get away from the head, as you move out the nose with weight, it tends to put more pressure and stuff and tends to outbalance things more. That's why if you go back and look at HoloLens, you notice they put basically a counterbalance. They put the entire compute pack behind the head, and that was to counterbalance the weight to the front. You tend to get poor light throughput. That's also kind of inherent in bird bath. Bird bath is far and away the most common optical structure I see used in AR, just all over. And then it becomes, becomes bigger with bigger field of view. It also tends to require the projection engine to be above the glass. When we look at these things front on, you tend to see this big area on top of the glass, and you'll see that in Nreal as well. What's happening here is you have to put the light engine on top because it's still got to have it kind of comes down, hits it, and comes back. Now you can't put it to the side if you go small, but when the small, like Google Glass actually did a bird bath, but they did a small one and they could come from the side. But as soon as you want any kind of size, you end up having to put the bird bath, this bird bath structure. By the way, the reason why they call it the bird bath is you see light rays going in, hit the mirror, and it comes up, and people say this kind of looks like a bird bath. There are 2 flavors of bird bath. There's one bird bath that the display goes down, hits the mirror, comes up, hits the mirror a second time, and comes to the eye. And this is the one we're seeing more of, which is where you look through the curved mirror. You come down to the beam splitter, hit the curved mirror. The curved mirror is actually doing some stuff to focus and then sending it back to the eye. The problem you have, and the reason why it darkens so much, particularly with this curved mirror in front, is that you have to go through this curved partial mirror, through this beam splitter partial mirror to get to the eye. So it's got to go through 2 layers of optics blocking. Therefore, it tends to dim the real world a lot. You also, because it's making all these bounces, it tends to make the efficiency bad coming from the display. The display also loses a bit. Still, it's orders of magnitude more optically efficient. More of the light from the display by orders of magnitude of an OLED will make it to your eye than it can through, say, a pupil expanding waveguide that we talked about earlier. As I said, these come in 2 flavors. They have a bottom thing. Usually these are encased. When they do the bottom type thing, they're encased. They tend to be a little heavier. You only have to go through 1 layer of stuff. You don't have to go through this outer curved mirror, so they have some advantages. But most of what we see these days, like Lenovo just announced the Think Reality. By the way, the Think Reality is almost exactly an ODG R9. It looks strikingly similar, and that's probably not an accident. Nreal is also very similar optically to the old ODG R9 that came out about 3 or 4 years ago now. As I said, Nreal, this is from 2 years ago, 2018. So the image quality is absolutely beautiful in terms of you're basically looking at a mirror image of an OLED display. There are a few problems. You do get some secondary reflections as the light bounces around in here. Each of these surfaces, there's some opportunity for some ghosting, and you do see some ghosting in it. But compared to most any other AR display, this thing looks quite good. And this is why you'll see people kind of heading that way when they want to get something. It's also very simple and fairly cheap, but it has the downside of you're going to block about 70% of the light. When you look through it, it's a lot, you lose a lot of light. The other thing we have in all of AR is that your background, your black, is whatever you see. So if you're looking at white concrete, you're looking at something that's pretty darn white. If you're outdoors, white concrete, 10,000 nits. If I took this Nreal headset outdoors in sunlight, you wouldn't see anything. It would just, all you would see is the white concrete. You might, you just have, only thing you know that you're wearing the Nreal is you've blocked 70% of the light. So it'll be 70% darker. But still, even if you take 10,000 times 0.7 or times 0.3, you're at 3,000 nits. And this thing is probably getting to your eye a few hundred nits. I'd like to bring up one here. This is a small startup out of Israel that I'm quite fond of the basic concept of this. I like it because it's simple. It's a small company called Ravn, and it's what I call super slanted. That's not their name for it. It's just kind of my generic naming of what it is. But what they've done is they've taken the prisms and the beam splitters and stuff like that and put them at this super slanted angle, a very heavily slanted angle. And by doing that, they're still able to optically get you effectively a mirror reflection. And so it looks really, really good. But we still have the problem that because there's no power in it, one thing that happens with this mirror is you're actually magnifying the image. The mirror is making the image bigger. When you do something like this, you don't have any magnification coming through here. So all the magnification has to be provided by your original projector optics. So whatever is taking your display, you've got to have the lenses. So your image out here can't be any bigger than the image up here. And actually it's by that distance away. Also, it has a fairly straight path. So it can't be done as flexibly. Another one that gets used quite a bit, this has been used mostly in military so far that I know of. For example, SA Photonics is a free-form optics. And basically it's simple, it's easily rugged, real good efficiency. The problem is that optically what they want to do, if you did a free form that you didn't see through, you don't need a corrector. But if you do a micro display into the eye, you have this kind of curved surface here that's also magnifying. Because of these two surfaces and all, you can correct most of the distortion. The problem you have is that you have to put a corrector on, because if you look through a thick piece of glass that's wedge shaped like this, you'd get a very distorted view through it. So what they then do is put a free-form corrector on, and you kind of see that all here. You've got the lens, you got the corrector. So what happens is you're now looking through an even thicker piece of glass. And that tends to be the downside to it. It gets kind of very big and bulky if you go to very high resolution. This makes a little more sense if you're looking at doing VR than AR, because you don't have to have the corrector thing. Another variant of freeform is a company called Two's. They basically built freeform into prescription glasses. And they've been at this. They're formerly Zeiss. As a matter of fact, a few years ago, there was some noise about maybe them working with Apple. As far as I know, that noise has died down. But they've kept on with it. Two's spun out of Zeiss. And, but it's basically a small freeform plus a Fresnel mirror that kind of redirects the light towards the eye. This is from their patent. This is from, actually, I think this from the patent. This from their from Kress's book again. But basically, they're allowed to route light into the eye. They get a relatively small image, and the image can't be in the center. This Fresnel lens does cause some distortion. Usually, it's right out, just out of the center of view, not very far, but just out. You also get a fairly small eye box, but not bad. It's workable. Generally, in this optic design, and this is quoting from Kress's book, you're limited to about 25 degrees. So it's a fairly small field of view. Another thing that gets a lot of talk, Google just bought out what was left of North. Bosch has been working on this. What they're looking at is a direct laser scanning off a holographic mirror. What the holographic mirror does is you can build a flat surface or even a slightly curved surface. But if you just metal coated this thing like a mirror and shot lasers at it, the lasers would miss your eye because the curvature of this thing, and you sometimes will see these things, and actually there's a C-Reel just has a product where they have this extreme curvature. But if you curve it like normal glasses or normal eye protection, the light will miss your eye. Well, what the hologram's able to do is effectively, particularly with narrowband light, it's from lasers, it's able to redirect that light as if the mirror was tilted. So even though the mirror, so instead of getting a mirror reflection, you get this kind of, you basically build a holographic mirror that bends the light more towards the eye. The downside of this, and you can see here, like in the Bosch booth, they're having to align this thing to your eye. So they have a whole fitting process, and North had a fitting process. They have a really, really tiny eye box. Effectively, the eye box is as big as your eye. Now, North did a replication of it to try to create a little bigger eye box and whatnot, but it didn't work so well. Anyway, it's very small, very light form factor, but the tiny eye box, the tiny field of view, the image quality is generally not all that great. So it's really limited to like what I'll call data snacking, and even then fairly limited data snacking. Another one that gets talked a lot about, and I'm not going to hit this one briefly, is a pin mirror. The idea of a pin mirror is you have these little tiny mirrors in here, and effectively you get what they call a pinhole effect. And because of that, it tends to, you're basically rejecting the out of focus light rays with this. It sounds good, but you're also rejecting a lot of light. So you do get a very high depth of field and depth of focus. That's true. But you do get hopping, what I call hopping. You kind of see here how the image kind of goes in and out. You get kind of dark spots. It's got this issue, and they're working on it, but it's not clear that you can make that. It's not clear to me yet that you can come up with a mirror size and a pin spacing, because you'll see like on the lower resolution ones, they tended to use larger mirrors and fewer of them. For the higher resolution, they went with a large arrays of tiny mirrors. This is the large array of tiny mirror version. You still get a lot of this hopping effect from things to things. So we'll see if that works out. The other one that's talked a lot about is pass-through VR. And I put this up here mostly because of some talk that Apple might be doing this. With pass-through VR, pass-through AR, which is VR plus a camera over each eye, you know, the virtual image quality is great. You know, if you use OLEDs, they can be plenty bright. You're not trying to compete with the real world light. You got hard edge occlusion, or the ability on a pixel level to block, you know, the real world is trivial. The computer that's in the headset just decides what to block. You need lower brightness to the eye, so you're not overtaxing the eye. The power efficiency is going to be great because you're not competing with the real world. And it's going to be much lower cost for the same resolution and field of view. Perhaps an order of magnitude less, if you try to get everything to equal. The cons, you're visually isolated, which is dangerous in the real world. You have latency. You have focus. It doesn't focus like the real world. You know, I don't know if they're going to do variable focus or what, but you're looking at a display. You're not looking at the real world. It doesn't. In the real world, we have infinite levels of focus. Everything at different distances focuses differently. Whereas in this headset, things are going to tend to focus at a given distance. Now you could talk about doing something like a light field inside this headset, kind of following on from the prior talk. You could try to do a light field, but it becomes highly impractical. You're going to do a real-time light field. What's going to happen to the latency and whatnot? It's just highly impractical. So the dynamic range is less in the real world. And there are all kinds of social issues. You know, do you really want to be talking to somebody who looks like the headset? Generally, the rule of thumb is that what's hard with optical AR is easy with pass-through AR, and vice versa. In other words, things that are easy in one are hard in the other, and hard in one are easy in the other. Let's talk about display devices. The most common display device used today is field sequential color. That may be changing, but that's the one that's been up until this year the most common one. It's basically the lowest cost micro display for any kind of resolution. The panel itself is low power, lots of pixel size, many suppliers. The other thing, it kind of cheats on étendue because the size of the light source is what drives the étendue, and the size could be a small LED. This is why you're able to deliver more than 3,000 nits to the eye, even with waveguides using LCOS. It's because the light is small. The cons are the illumination path. You have to illuminate these things, and that can cause issues. The uniformity tends to fall off. It requires polarized light. So right off the top, you lose 60%. It's not as bad as it seems sometimes in near eye displays, because oftentimes they use polarizing optics. It's more efficient in a bird bath, for example. And then you have field sequential color, which is a big issue. It breaks up. That can be a real problem for people when you move your head. Very common, people who used HoloLens 1, if you moved your head around, you noticed how you saw it. Now, they used a really slow field sequence rate on the HoloLens 1, and so it made it really bad. But it can be faster. There's some LCOSs now that are faster, such as Compound Photonics is claiming a very high rate. There's latency with the field sequential because you got to kind of build up the color and display it. Once again, Compound Photonics is working on something to address that. But it'll always be some more latency than you would have with a non-field sequential display. And there tends to be a little bit lower contrast. I'm not going to talk much about DMD. DMD seems to be kind of fading in AR. I think they have some real advantages in non-AR markets, non-headset markets, but I don't see them getting used a lot. And even some of the stalwarts, such as DigiLens and Wave Optics, that were almost exclusively DMD, have been moving to LCOS. So I get the sense that there's a thing. And the problem is that when we build these really, really tiny displays, LCOS is flat and planar. The mirrors that they use are built on top of the silicon, whereas with DMD, they move. And because of that, there tends to be more gaps, and that all translates into bad things like diffraction and whatnot. And it's just, LCOS is a lot less expensive to make, particularly at higher resolutions. So all those things tend to work in its favor. DLP still has advantages. The one company I know using that's been using DLP lately is C-Real. C-Real's doing once again, a Lightfield type device, and they are using the very fast switching mirrors to help with DLP to help them accomplish that. Like I say, it's brighter, tends to be brighter, but generally the power consumption up front tends to be more of a disadvantage than the advantages they get from, say, not requiring polarized light until you get to really, really bright images. As I said, the Etandu is controlled, like here's the Lumis engine. They have a really small LED that tends to control it. There's a Lumis clone, kind of shows the path that the LED is much smaller than the display. At one time, I thought Apple was maybe going to use LCOS with using their Aconia stuff. There's some Aconia patents on showing how to reduce. Traditional beam splitters are very thick, and this is really bad optically. This creates all kinds of problems with a thick beam splitter, called what's known as a working distance. Makes it much harder to build the projection engine and whatnot. Aconia, which is owned by Apple now, they had a way to have a fairly slanted thing. And Hymax also does a thing with light guides. So there are some tricks to do there. And I'll talk a little bit later. There's a thing by DigiLens. Here we go. DigiLens actually has got a new thing called their, they got their new product that they're talking about. They've got actually some working samples now that has about only a 3 cc engine for 50 to 70 degree field of view. It uses 3 lasers, and kind of in reverse, it's using the waveguides to route the light from the lasers to the LCOS and combine them and get it out. So they get a very, very thin optical path there. Compound photonics, interestingly, this appears to be a compound photonics panel they're using. Compound photonics put out their own 3 cc, much more conventional engine, although they're doing some trickiness to pack it all together. You can see how the DLP engine's a lot bigger. These are roughly to scale. Now, lasers in theory are small. Laser beam scanning that was used, say, on HoloLens 2. But actually, because of all the conditioning and ways in which they have to manipulate the light, they actually end up with a fairly large light engine. The optical engine is actually quite large. It's several times the volume of any of these other engines. Oh, and then we have kind of foreshadowing here, going to micro LEDs. They end up with really tiny engines because they don't have to do this illumination path. The illumination path is generally about 2/3 of the engine. So if you eliminate the illumination path, you can get a really tiny light engine with these things. But as I said before, both of these are using waveguides. I wonder about the efficiency, in-to-out efficiency getting through here. Don't think I'll talk too much about field sequential color today. I wanted to I've done a lot of studies, and look at my weight. I've got a lot of this on my blog. I've gone into great depth on how HoloLens works, how it scans. It's a messy process, and it's really poor image quality. Anyway, any realistic way you want to measure it. And I stand behind the fact that I think I've taken some of the best quality images and most representative to the eye images that I've seen anywhere ever taken of HoloLens. I didn't just stick a cell phone. You're not going to get a good image of HoloLens just sticking a cell phone in front of it. I went through a lot of work to position it properly, use good cameras and all that. But this is interesting. If we actually look at HoloLens 2 from HoloLens 1, this is a HoloLens 2. The actual resolution of HoloLens 2 is much worse. Even though they claim it's higher, it's not. If you go out and measure it any way you measure it, or if you take a human and take a HoloLens 1 and a HoloLens 2 and swap them, like put one on and swap them, it's immediately obvious that the HoloLens 1 is vastly higher in resolution than it. And I've detailed this a lot on my website. So I suggest you go there, go to my website, and you'll find and look up for HoloLens 2, and there's all kinds of information on it out there. The only thing I want to say here is right now, if you think about LCOS separates the light generation, the LED, from the LCOS device, from the display device. In the case of an OLED or a micro LED, the display device has to generate the light as well as control the light. Because of that, you're now running the light or running the power into the thing. So now you have to have a more complicated pixel, and the pixel has to have structure in it capable of handling current. In the case of LCOS, it's static. You're just driving you take an electric field, it's basically a capacitor. You drive an electric field and you make the liquid crystal work. So that's the key point here. Oh, one other thing. Because LCOS is field sequential color, you only need one of them. Whereas if you're going to go with a micro LED, if you want a panel, if you want all of the colors on one panel, you got to put 3 sets. So it's more complicated and you need 3 of them. So that's one of the reasons why OLEDs and micro LEDs are a lot more expensive than, say, LCOS is. Like I say, micro OLEDs, very, very common in low cost, high quality type images. To get a low cost, high quality image has drawbacks, but it's going to give you the best image quality of any of the headsets I've seen today. Better than every other technology. It's better than even micro LEDs today, and I'll talk some about why. Extremely high contrast, it's self-illumination, so it leads to a fairly small size. All that. The downside is it's what we call Lambertian light. It's like that. Remember my spray pattern of the light. It's spraying light everywhere. It's going to get you maybe 3,000 nits today. By the way, most of the OLEDs you buy are less than 1,000 nits. So the high brightness ones are maybe 3,000 nits today. The super high brightness ones coming out might get you to 7,000 nits. This is ridiculously too low to go into a pupil expanding waveguide. You'd get maybe a nit out, so you'd barely be able to see it in a dark room. You know, like I say, Copen and Imagine are promising 30K in 2 to 3 years, but that's still not enough to go into a pupil expanding waveguide. So it's much lower nits. There are burn-in lifetime issues, just like you hear about with televisions and whatnot. It's higher cost. It's generally lower resolution than you can get LCOS at because they're going field sequential color. These guys, if they're going to put 3 pixels, so this guy only has to put 1 mirror down there and sequence the light, so he can generally get higher resolution in the same size. But it's and as I said, it's Lambertian light. The big talk is micro LEDs. And this seemed to be the Valhalla thing. You heard all these people talking about 1 million nits and 5 million nits. And when I first heard about it, I thought, well, man, we have 5 million nits. We can drive anything. But you got to look a little more carefully. It's good. It allows for things. But so it's millions versus thousands. Compared to an OLED, it's millions versus thousands of nits. So it's about 1,000 times brighter, potentially. It's better energy conversion efficiency, better fill factor. And this isn't an exact number, but from what I've been able to gather, it's about 10x more nits per watt. So then you might say, how do you get the extra 1,000? So you went from, if you think about it, if it's 1,000 times more nits, then 10x, where do you get the other 100? Well, you get the other 100 by driving it harder. The big part about it is that you can drive these LEDs a lot harder than you can do OLEDs before they burn up. So you have a smaller emitter, which means you get better étendue. They get more leverage out of small micro optics. They even build optics into the structure of the LEDs themselves on some companies. So it's orders of magnitude faster switching, which means you can start doing some neat stuff. Like talked about DLP earlier. DLP was they can switch fast. That's where C-Real was able to do a Lightfield. Well, if you have micro LEDs and you can control them, then in theory you could do all kinds of neat stuff. They can be driven much harder, and that's much of their brightness advantage over LEDs. They can be driven hard. They're about 10x more efficient, but like I say, a lot of that's coming from there. It's narrower spectrum, which can be an advantage with some filters and stuff. And then you've got so much going on in LED manufacturing. The con is it still has étendue issues with waveguide. This is the big conundrum today that I see when I talk to the real experts in optics. Is the conundrum is it's still got an étendue problem with respect to waveguides. It will work, but it's not very efficient. Now it does have the advantage, and so does OLEDs, that if you're not driving a pixel, you're not consuming power with it. It's very efficient. Whereas LCOS, you illuminate the whole thing. If you put up black, then the LCOS is just blocking all the light. Here you don't block light, you emit it. And so if you're not emitting light, it's fairly efficient. If we look at most AR applications, they should be sparse. We're not trying to put a movie up there. You're trying to draw on the real world with something. So as long as you're providing sparse information, then you can kind of deal with this power inefficiency, so long as you're not trying to do too much. But it's high cost and very low yield to date. It's very poor pixel to pixel brightness uniformity. You're not going to want to watch a movie on it anytime soon. It's really more for this sparse data. Right now, the ones who are like Jaybird is going to production, they have high nits, more than 1 million, but it's only a single color. Or you could do 3 chips, and this is being shown by, for example, Vuzix. 3 chips with waveguides are possible. A Stendo has RGB, but it's lower nits. And in Stendos, I've seen working units. So they do have full color. This is kind of the space. We have Plessy, who was just bought. Plessy was, of course, bought by Facebook early this year, basically right after CES last year. Stendo has figured out how to do full color on a backplane. Compound Photonics, who was working with Plessy, has gone out on their own, and they're doing their own micro LED, working with partners to do the LED portion. Jaybird is probably the guy closest to production. You can go buy samples from them, and they're announced that they're going to have samples in production later this year. But it's a complicated process. You got to build a silicon backplane wafer. You got to flip the LED. You got to build the LED separately, flip it on it, get into bond, get it to yield. Glow's been around doing stuff. Vuzix was, we'll talk a little more about them in a minute, but Vuzix has announced that they're getting ready to go to market with some new glasses with a waveguide. Very, very small and tiny. Basically, this is a variant of it. This is where they were a year ago. They're in the process of productizing this into a product. This is what I wanted to show you, though. This is from Plessy. I shot this with literally handheld. I was surprised it came out as well. But this is a photo micrograph I shot of Plessy at last year's CES. And what I want to do is blow up this one region. And what you see is I was able to find the original source material. And you see the original source material is very smooth, particularly in this area. But it's very grainy in the image I took. And the reason why is that all of them, and I see the same thing in Jasper, I've seen the same in every micro LED I've seen with my own eyes. It's always kind of grainy looking. And the reason why is that the brightness is varying dramatically from LED to LED. And I don't know if this is part of the process, part of the transfer, what. But these aren't just dead pixels. You will find dead pixels if you look enough in these too. But these are all prototypes, so that's not, that we're at that stage. But it's still very grainy. I think that's going to be a bigger problem. So you're not going to want to watch movies on them, but this is probably acceptable if once again, you're trying to point out things in the real world. Plus, Facebook has been on a spending spree. They bought, a few years ago, they bought InfiniLED, and they didn't exactly buy Plessey, but they locked them up. They've locked up all of Plessey's ability to sell micro LEDs, at least to the display market. Remember I talked about earlier that they're building structure into the stuff. So they actually built a mirror in InfiniLED. What they were doing is building structure into the silicon substrate to build these little mirrors. This is all about collimation of the light, trying to get the nits up for the given amount of light that's emitted. These are some pictures from last year at CES. So this is about a year old. This is a Jaybird fine line drawing. I wouldn't take, they've had some electronic bugs, but that's once again expected. They're showing early prototypes. That's not a real problem. That's a temporary problem that's going away. They also showed with wave optics at the show, they showed their micro OLEDs working with the wave optics. Once again, if we look at these things really close up, you see it's kind of grainy looking. If you look over here, this is even a closer look up at a blue one. You see how it's real grainy looking. That's where they're at with LEDs. They have a huge amount of variation from pixel to pixel. The one guy out there who can do full color, and I have seen it a few times, is Stendo. Stendo is a little company down in Carlsbad, and they've been at it for a lot of years. But they're the only guy I know of who's got really what I'll call a monolithic full color process. Instead of having the pixels side by side, they literally can stack them on top of each other. They put micro optics on top to help collimate and polarize the light. And so they've got this thing they call a stacked pixel. So they're the only guy I know of right now who has a single chip full color one. It's fairly low resolution, it's lower brightness, but they are the only one with a micro LED with full color. Yeah, just to hit a few things here. Vuzix, this is from a Vuzix video. They're talking about doing monochrome green. I have not been told, but it doesn't take a tea leaf reader to figure out they're probably using Jaybird. They're also looking at doing, they showed in their video a color one where they throw 3 stacks. I think what they're doing is they're probably taking 3 waveguides. This is what Digilens did with their Wild and their laser. You basically take 3 waveguides, only they're going to be imaging waveguides. So what they're going to do is it's kind of like the reverse of what Digilens did. And they're going to take 3 waveguides and bring the red, green, and blue in. And by the way, that's what Magic Leap did. Magic Leaps were spatially separate. Their red, green, and blue came into their 3 waveguides in separate places. So that basically you just bring the image in 3 separate places and combine it in the waveguide. I have a saying in this industry, if you can think of it, Facebook's already tried it. And I think that's pretty well true. Almost every time I see a new concept, I can go digging for it and find out where Facebook wrote a paper about it or where Facebook filed a patent on it. So real quickly wrapping up, and I'll those who've got YouTube and all can pick this up. It's also on my website. I've been trying to map out how the world of AR displays maps onto the optics. So basically what I say is various optic solutions map onto various different types of optics. So over here we have our optics, over here we have our display devices. And kind of, this is one of the big factors today, is can you get micro LEDs to map well onto diffractive? There are issues, mainly this étendue issue. So diffractive waveguides have bad color. We're waiting to see if reflective waveguides can work well or can be cost effective and manufactured cheaply. We have holographic reflectors, which just don't believe that's a very good way to go myself. Freeform optics has a lot to say if the image resolution is small, particularly if we're talking twos. Within freeform, you have things like twos. And twos has shown that they could do something if you're willing to do, if what your task is needs not a lot of data. I'm actually kind of excited about this rim super slanted that I've talked about. And then there's other things you can do. But most of the attention is going up here and a lot with bird bath with either micro LED or micro OLED. Right now, the hottest thing probably is here. And I'll talk about why in a minute. There's three guys in the what I call the billions per year club. You got Facebook. They've got a huge team of smart people working on this. And as I said before, if in AR, if you can dream of it, Facebook has tried it. Apple, by searching around and looking at papers and looking at patents, you can't see Apple putting in the half or a tenth the level of effort of Facebook. Now, maybe they're doing it. Maybe they're keeping it quiet. Maybe they're working through shell companies they bought. For example, Iconia still files patents as Iconia. They don't file patents as Apple. So it gets a little harder to follow the paper trail on Apple than it is, say, on Facebook, who's got this major facilities and lots of people and publishing excellent papers and with some of the biggest names in the industry. Apple, multiple reports are using Sony micro LEDs. At first, I thought they might be using Iconia, which is something they bought. But if true, Apple's is not using a classical waveguide. They cannot be using Iconia. So by process of elimination, you say, well, if it's pass-through AR, super slanted might be a possibility. They might go pass-through. They might do something like a rim, or they might go bird bath. But bird bath doesn't, that's like basically going to look like Nreal, or going to look like ODGR9, going to look like everybody else. That doesn't feel very Apple-like to me. Robert Scoble on the AR show, give a plug for that. That's an excellent show, by the way. Jason McDowell does a great job with that. Asks great questions. I was on, I think, his second or third show. I think he broke it into two parts. So there's like 3 or 4 hours of me talking if you want to hear more. But Robert Scoble, who's kind of, I'll call it an industry gadfly, but he was very famous in the days of Google Glass and whatnot. He was just interviewed a week or so ago, or just published a week or so ago on the AR show, said that Apple is using pass-through AR with a flip-up screen. It's plausible, definitely plausible, but man, I once again have a hard time seeing how that works. And I sometimes think that they're going to delay and then claim it was due to the pandemic. I just, and then Microsoft has so far retreated to the existing market of enterprise. There is a real enterprise market. Microsoft's exploiting that right now. There are things there where if a guy, you can save a guy, you can say, you're paying this guy, fully loaded guy working on a factory floor, probably over $100,000 a year. If you look at salary, benefits, equipment cost of facilities, all that stuff, you're probably costing more than $100,000 a person. You sit there and say, hey, if I can save you just a few percent of his time, it pays for itself. And that's the argument that wins the day right now in AR. That's why I think where Microsoft's having success. The image quality sucks. It absolutely does. By any rational measure, it's a crappy image. But it's linked to the real world. It puts a spot on a thing in the real world that says, tighten screw here or whatever. So the real thing is being made not by putting out great movies, not by the things you see in Iron Man and all the movies. It's being made by people who are basically saying, this is what AR lets us do today, accept it, and then say, what could be useful by this? Like I often say, if AR would, if all AR took was money and smart people, it would be here already. And I think, like I say, Google found that out. I think that's it. I'm sorry. I know I ran a lot longer, but hopefully it was good content. That's it for me. I don't know if we have time for questions or not.
Thanks, Karl. Let's just do couple of questions from the feed.
Yeah, so I can post that question on a Zoom chat so you can select which one do you want to answer.
Okay.
Because there's a few of them very good.
Okay. If I can get to that.
It's all on the Zoom chat.
Yeah, I have to close down my share window to see the Zoom chat, as far as I know. Okay. Okay, I see one question is, what's my thought on micro LED from Jaybird? They're there, they're available, they're not perfect. Driving them is kind of tricky. I don't know that they're really a tie-up with Vuzix. I think that's just more a partnership of convenience. I mean, I'm pretty sure Vuzix has been providing their development kit waveguides. If you look at it, it looks exactly like what they showed at CES. So, but I don't think there's anything really special. And then the other question was the AR system from Karl. Well, I hit on some of that with the pin mirror stuff. I've run that up the flagpole. The idea of a scanning, like micro LED scanning, I don't think they're going to get it to work. In my personal opinion, they might, but I think they're going to have a hard time. And I've talked to people in the industry about this idea of scanning a linear array or a kind of a two-dimensional array that you scan to make it do even more resolution. And you have some subarray, say 1/10 of the pixels, and then you scan it around and all. And everyone's pretty skeptical about it, that they'll get that to work. And then the question is, will it be bright enough when you do all that? I was intrigued by it at first, but the more I run that up the flagpole, the less. The C-Real Lightfield display showed at CES this year. I haven't seen the very latest one. I know they were using DLP. I've studied. They actually have an excellent patent. If you look it up on free patents online, you can look up their patent and it explains how it works. It's actually a really fun read. The patent's excellently written. I'm still a bit skeptical they're going to be able to get it to reduce to the form factor they want. It feels to me like they need micro LEDs to even make that happen, because they need the time sequence. They're basically using time sequential, whereas you did spatial with the Leia and did spatial. They're doing it time sequential to get the light fields up there. And they've got a tricky thing with how they illuminate. They're basically illuminating the LED. How they're going to make that work if they switch, say, someday to micro LEDs, they've got the speed, but now they've got to do something to make the light come from different angles and directions. So I'm a little skeptical on it. They're smart guys. They're nice guys. And I wish them well. But I think it's going to be harder than they think to get that reduced to the form factors that they're showing. What's the requirement of display? You know, it's really the character light. You really kind of want for these waveguides. I mean, they're going to lose a lot of nits. So you're looking at needing like 1 million plus nits into the waveguide. And it really depends on the character of the nits and will it fit in the hole. You got to talk this Eton-Do thing, which is really complicated. But you've got to be able to get not only collimated light, but you got to get it to fit into the entrance area of these waveguides. And then we get back to, well, diffractive waveguides have really bad color control. So you still get a pretty crappy image. So it's really tough going that way to get there. That's why I kind of like, I like that super slant from Rim a lot, because it's got the, it's more optically pure. It's optically simple. It has issues too with how you're going to get the image big enough. So there's a field of view issue. Yeah, the main difference between a rim and Loomis. Loomis has pupil expansion, so their reflectors are actually all reflecting the same image, in multiple places. With a rim, the waveguide is much more slant, or the mirror is much more slanted, and there's only one mirror. So in one case, you have multiple mirrors, each kind of having copies of the whole image that you see in it. So when your eye moves, you see the whole thing. With a rim, the image is coming in, not collimated. You're getting a more diffuse image. So like a rim can work with OLEDs, and they are working with OLEDs. You could never use an OLED into a Loomis. There are different pros and cons and take a long time to explain. Let's see, what solution is best? You settle. Well, there's no best. I like that a rim thing a lot right now. TUS is pretty good TUS is good if you need to do like data snacking, because it's all form factor, very rugged. I mean, one of the things I like about TUS is really rugged form factor, and you've got a big name, you know, they're working with Zeiss, and so they got a big name company behind it and all. So there's a lot to be said there. I'm not real big on the laser scanning off, ricocheting off a hologram, because the eye box is so tiny, it's a problem. Let's see, other things. I hope I hit most of these. Yeah, I say it has low nits. I don't know their exact number for Estendo on their nits. They're claiming hundreds of thousands of nits. I don't think they're delivering that today. I think they're delivering in maybe the 10,000, maybe 20,000 nit range, which is way beyond where OLEDs can actually deliver, but they're not nearly as bright as the others. The stacking structure, I think, makes it difficult to do that. They're definitely aiming, they can't be aiming at waveguides. They've got to be going for non-pupil expanding. When I say waveguides, actually, a rim is a kind of waveguide by what people call waveguides today. Really what I mean, usually when I say waveguides, I'm really saying pupil expanding waveguides. You just can't do the pupil expansion. You have this étendue loss followed by the pupil expansion loss. And when you do that, nothing comes out. You basically have thinned it out to the point that you can barely see it. It's like looking at the sun from planet Pluto or something. Let's see what else. You mentioned a variety of issues with HoloLens 2. They were plagued by quality issues. Tried one recently, and none of the original, I'm sorry, I should read these. It had none of the original color fringing and focus issues or light bleed issues I saw in the original one. Okay, so you felt like it was slightly better than Magic Leap. I know they've been working on it. I heard they did something that some people say hurt the resolution a bit, but made the color rainbowing less. Fundamentally, the laser scanner, even under the most ideal conditions, is like a quarter of the resolution they claim for that thing. I mean, there's no way they're using two lasers. I know how they're scanning it. Like I say, go to my blog, it's not there. I do hear that they are improving it. I heard that there's really severe criticality in how the lasers and the alignment and the placement and everything is. It's like super critical. And that's why they had such huge variation initially. And apparently they're locking that down. They've done something with some kind of filtering or some kind of changes to the waveguides that apparently has improved the rainbowing colors a lot. But when they're all done, they still going to have the scan rate of the HoloLens 2 is way too low for the resolution they're claiming. I mean, that's a fact, and I'll go to court on that. Okay, that the resolution is far too low for the resolution they're claiming. Therefore, the display flickers, the text flickers. Text is going to be a problem forever. I grew up in the I started in the display industry really in '77. I worked on a video game chip, and I've been dealing with televisions and flicker. In the 80s, late 80s and 90s, they made it illegal, basically in Europe. They passed standards that said you couldn't flicker as bad as what HoloLens does today. Their scanning speed is just way too low. So it's got its pros and cons. It's still kind of the winning there, because in the land of the blind, the one-eyed man is king, so to speak. They did do one thing. I do like they did say, forget image quality, forget a lot of things, but let's focus on making it comfortable. Let's lock it to the real world. Let's get something out in the market. They give good eye relief, which is hard to do, so that you can wear it with glasses. They have one of the more practical products out there. And I think that leads a lot. So they did a lot of things, but the display I still think is really pretty poor. Fortunately for them, and what they realized is that you really don't need a very good display. You talk about it, you market it like it has a great display, but it's kind of emperor's new clothes. If you really know anything about displays, it's a horrible display. Mojo Vision. That's a good one. Yeah, there's some basic physics problems with Mojo Vision. What they're doing is they're basically building, if you know a telescope, how a telescope works with a mirror, they're building a sub-miniature telescope in reverse in front of your eye. The problem is, and it's actually very related to the Letten AR problem of the pinhole. If you're going to put this right in front of your pupil, it's going to disturb the view of the real world, because the light, a lens is collecting light. And what happens is it's taking light from a patch in the real world and focusing it on your retina. Well, you've just put a dot, if it's aimed right in your eye, you just put a dot blocking out the nice, easy, good, solid rays. And the only rays that are going to make it to your eye are those outer rays, which are harder to focus. So you're going to hurt the image in the real world. There's also a limit to how small they can make the pixels. The wavelength of light, like green, is 530-ish nanometers. They can only put so many pixels up there before that thing gets so big that you can't even see out. So it's going to be, for at best, very limited data snacking. Yeah, I could see it for spy work and maybe a few military things, but it's never going to be a consumer-y thing. And there's other issues too, but I'm pretty good. Yeah, as I said at the beginning, people like reading my blog when it's not about them, because I tend, as an engineer, I'm very analytical, and I tend to find the faults in things. So there probably are some good things about all this too, but I tend to find the faults. So I think we've answered a lot of questions. I don't know if I don't know anything about Magic Leap 2 coming this year. What's kind of thought of micro LEDs from Dave Burns? I think we've hit almost all the questions. So,
yeah, thanks, Karl. You did a fantastic job, and thanks for answering all the questions as well. There's a few other events coming up, which the audience might be interested in. Sasha, would you mind sharing a couple of those?
Right. So if you want to so we actually please follow us on the Facebook group. We're actually posting like different types AR/VR events, not only our groups, but it's other coming the workshops, events. So please following. And yeah, the presentation was awesome. To be honest, I learned a lot, like insanely.
thanks.
And what are the best way to contact with you? Because I saw you posted website, and what is the best way?
I did give my direct email, but you can get to me through the website, particularly through the comment section. If you're a first-time visitor, it shouldn't post if you tell me, hey, don't even print this. So you can go through my website, or you can go directly to Karl, which with a K, at kgontech.com, kgontech.com. Either one of those two will get to me. If you look at the name of the blog, it's KG On Tech. I made a really silly mistake early on in starting the blog, like over 9 years ago. Otherwise, the name of the blog would have been KG On Tech, or the web address. So I hate to do the consolidation. I guess at some point I ought to get those two to merge. So, okay.
Thanks. And yeah, thank you so much, Karl and Nima, for your presentations. These were terrific. And
Thank you for having me.
guys, I'm really blown away by the turnout we had today. And sorry about the technical issues we had earlier on. So we're going to be looking at some different approaches for the future meetups. And but I'm really excited about what we have lying ahead for us this year. So, and thanks, Sasha, for organizing the questions and the Facebook post and everything else. So, well, take care, everyone, and have a great rest of your day.
Yeah.
Thank you.